Hello and welcome back to the channel Understanding Concepts of Physics. As we are doing logarithms, we are here with the second example, and it's more trickier than the previous problem which we had taken in the previous video. If you can see on the screen, let's just quickly start with solving this one. And the number is 2.817 multiplied by 389 the whole square divided by 450 into root of 3. So this is the question we are about to solve using logarithms. I have found out the answer with a scientific calculator, and that has come out around 546.9. And now we'll try to figure it out whether using logarithm also will yield me 546.9. So let's just quickly start. Before we start, I would like to highlight that there are rules of logarithm. Wherever there is a multiplication sign, we are supposed to take a plus sign, and wherever there is a division, there will be a minus sign, and whatever the power is in the power of the number is given, we can take it ahead in logarithms. Now just the concept of root 3 is when you write root 3 somewhat like this, root 3, when there is nothing written over here, that means there is a 2 over here, it's a square root. So we can write this 3 as raised to 1 by 2. So whatever is power over here, whatever the number is at this point, you can just invert that and put a reciprocal over here. So if I had a let's say fourth, let's say cube root of 4, then I could have easily written as 4 raised to 1 by 3. Now once it is in power, using logarithm ka property, we can bring this power ahead. So that's one thing which is somewhat new to in this problem. Let's just quickly start. So this is the question. I have found out the log and I have just placed it everything so that the video becomes shorter, and you can just copy it, or you can just do it on your own as well. Now, so when you apply log, you also apply an anti-log. So when you apply log over here, you will also have to apply an anti-log over here. So the entire bracket is logged and anti-logged. So anti-log stands outside and with a square bracket. So this is that anti-log ka square bracket. Then you apply log for each term. So 2187 is logged, 389 is logged, 450 and 3 is also logged. But note that wherever there is a multiplication sign, there I have put a plus sign, and this 2 should be brought ahead of log. So this 2 has to be brought ahead of log. Same way there is a division sign, and because there are two things in the denominator, I have used a curly bracket over here so that everything goes into the denominator. Now this is my personal suggestion that in case if there is more than one terms, like 1, 2, there are two terms, so use a curly bracket, because there is a chance that you may not change the second sign. So use a curly bracket. That's all to conclude here. Then 450 log of 450, wherever there is a multiplication sign, put a plus sign. Now this is a 2 over here, so when it goes to the power, it becomes half, and with the property of log, I can bring that half ahead. So this half has come ahead. Now a very common mistake is that students initially multiply this with 2 or half multiplied with this 3, and then they find out log, which is a wrong way of solving. Initially what you are supposed to do is you are supposed to find out the log of 389 and then you multiply by 2. Initially you find out log of 3 and then you multiply it by half. Now let's just quickly find out the log of each number. So this is a number which is greater than 1. So because this number is greater than 1 and I am seeing that there is only one digit before the point, so the characteristic would be 0 point. Then 2817, so 28 row, column number 1, and mean difference is 7. So I'll get a 4498 in that number. Now in case if you are finding it difficult to find out this 2.817 and how to get this step, if you are finding out difficult in this step, I would request you to go back to the previous logarithms videos, initial videos, and come back to this video again, because I have clearly explained how do you get this number. Then 2 as it is, and when I see this number is also greater than 1, and when there is no decimal point seen in the number, it's always at the end. So you have 1, 2, 3, there are 3 numbers, so the characteristic would come out to be 2 point. Then mantissa should be 38, 9. So 38 ka row number, 9 ka column, and mean difference would be 0. So mean difference won't be there. So that comes out to be 5899. So you should keep a logbook handy in case if you are just trying to tally with my numbers. Then comes 450. This number is greater than 1 when there is no point, there is a point with the end. 1, 2, 3. There are 3 numbers, so the characteristic is 2 point. Now 45, 0. Row number 45, column number 0. You get 6532. Half as it is. Now this number is greater than 1, point is at the end. There is only one digit before the point, so the characteristic is 0 point. Now if this is 3, then you can just have n number of zeros over here. So that is 30, 0, 0. That comes out to be 4771. So we have found out the log in this particular step, and now it's up to the multiplication and all. So first initially we'll multiply this and we'll multiply this too. So when you multiply 2 to this number, you get 5.1798, and when you cancel this, 2 ones are, 2 zeros are, 2 twos are, and so on and so forth, you get 02385. This number is as it is, this number is as it is. Next, what we have done is we have added these two numbers. So I got 5.6296, and I have added these two numbers, I got 2.8917. Then I have subtracted it. Now it's my personal suggestion that while solving by log, you always have to write it somewhere and then do it, because there is a chance that you will make a mistake. So if you see, this is 6, so 16 minus 7 is 9. This is 8, 8 minus 1 is 7. This is 12, 12 minus 9 is 3, and this is 5, so it will become 15, 15 minus 8 is 7, and this is 4, so 4 minus 2 is 2, so 2.7379. 2.7379. Now if you wish to find out the anti-log, then anti-log is always found out, the mantissa is found out the first, so always begin after the decimal. So I have found out the decimal, you go for 7379. So 7379, I get a number as 5469. I'll just write over here, 5469. This is the number when I see 73 ka 79 in the table of anti-log. In the table of anti-log, just pay attention, in the table of anti-log. Many people search it for in log and make a mistake. So 7379, row number 73, column number 7, 9 ka mean difference, add them up and you will get 5479. Then put a point after the first digit, put an into, put a 10, and whatever number is just ahead of the decimal point, you need to put that in power. So your answer would be 5.469 into 10 raised to 2. That's it. This 5.469 10 raised to 2 is as good as 546.9, which I had already got from a calculator, scientific calculator. So we are getting, sometimes the answer might differ by some 1 or 2, and that is fine. I mean, in logarithm you will always get an approximated number. In case you are still with me, subscribe the channel in case you haven't done so, and keep following the videos in a link. Thank you so much for watching. Bye.